Good morning, students. Today we are going to revise chapter 3, that is elements, compounds and mixture. Elements and compounds you have studied in the previous class. First of all, you see that the matter we encounter every day is always a complex mixture. For example, the air we breathe is a mixture of various gases like nitrogen, oxygen and the noble gases. Other example like milk. It is a mixture of fat, proteins and water. However, there are few examples where the matter that we encounter in ordinary experience is pure. That is, it consists of only a single substance. For example, distilled water, sugar, baking powder, salt, etc. These are pure substances. Why? Because it consists only a single atom. So is the copper that we use in electrical wiring, or gold and silver that we use in jewelry making. These are pure substances. But it is difficult to extend the list of pure substances much further. Even such a pure looking substance as ordinary table salt consists not only of sodium chloride salts but also of small amounts of additives that delay damping. So it is clear that all the matter around us is not pure. In fact, the matter around us is of two types, that is pure substances and mixtures. Now, a sample of matter containing only one kind of substance is called a pure substance, and a sample of matter containing two or more substances is called a mixture. Now here in this chart, as you can see, that matter is divided physically and chemically. Physical properties means what? The properties of matter which can be observed without changing its composition or constitution under specific conditions. These are called physical properties. Like for some example, if I'll give you, then the example will be color, density, melting point, boiling point, its hardness, malleability, ductility, etc. These all are physical properties. And what about chemical properties? Now all those properties of matter which can be determined when it undergoes a change in composition or constitution either alone or by interaction with other substances are called chemical properties. Okay, like for example, if I'll give, then when a piece of sodium metal is dropped into a beaker containing water, a vigorous reaction takes place, as a result of which sodium hydroxide and hydrogen are formed. So this is the example of chemical properties. So physically, matter is divided into three states, that is solid, liquid and gas. In chapter 1 you have studied this one. And what about chemically? Chemically, matter is subdivided into two parts, that is pure substance and mixture. Pure substance is further subdivided into elements and compounds. And elements is further divided into metals, non-metals and metalloids. And what about mixtures? Mixtures are subdivided into homogeneous and heterogeneous mixtures. These we have discussed earlier also in the previous classes, in the previous lectures also, right? So we will not discuss this in detail. Today we are going to discuss about the difference between elements and compounds and elements and mixtures. First of all, we are going to see the difference between elements and mixtures. So elements are homogeneous. So homogeneous mixture means what? A mixture has a uniform composition throughout its mass. It has no visible boundaries of separation between the various constituents. For example, sugar in water or lemonade. Air is also example of homogeneous mixture of oxygen, nitrogen, rare gases, then carbon dioxide and water vapor. So elements are homogeneous. What about mixtures? Mixtures may be homogeneous or heterogeneous. Okay, homogeneous means it has a uniform composition throughout its mass. Suppose if I am mixing sugar in water, it is a mixture, but it is a homogeneous mixture, right? Then what about heterogeneous? Heterogeneous mixture is that in which the composition is not uniform throughout. Because of the uneven distribution, the constituents of the heterogeneous mixture are visible with naked eye, or at least under microscope. Like a mixture of sand, salt and iron filling is a heterogeneous mixture in which each constituent can be easily picked up by hand. So these are the example of heterogeneous mixture. Now elements are made up of only one kind of atoms, right? For example, Na, that is sodium, then hydrogen, these are made up of only one kind of atom. But what about mixtures? They are made up of different elements and compounds, or mixtures are made up of different elements and compounds, you've seen. Then third point, elements are composed of only one kind of matter and have constant composition. Mixtures are variable composition. Then elements have definite physical properties such as density, melting point, boiling point, etc. But mixtures do not have definite physical properties. Then atoms in element are held together by strong force of attraction, that is intermolecular force of attraction. But in a mixture, the components, there is no force of attraction between constituents of a mixture. So this is all about the difference between elements and mixtures. Now we are going to see about the difference between compounds and mixtures. Now we are going to see about the difference between compound and mixture. So compounds are chemically bonded, mixtures are not chemically bonded. What does it mean? It means compounds are formed as a result of chemical reactions between two or more elements or compounds. But mixtures are formed by simply mixing two or more constituents. There are no chemical reactions between the constituents. Now, as you can see, the second point, components of compounds cannot be physically separated. That means the constituents of a compound cannot be separated by physical or mechanical means. They can, however, be separated by chemical methods. Components of mixtures can be physically separated. Means the components of a mixture can be easily separated by physical methods. Now this point, ratio of components is fixed. This means the components of a compound are always present in a definite ratio by mass. For example, H2O, 2 atoms of hydrogen and 1 atom of oxygen. It is always fixed. The ratio is always fixed, 2:1. Right. Then ratio of components in mixture may vary. Means the components of a mixture may be present in any ratio. Like if you are mixing sugar and salt, it is an example of mixture because you can take any amount of sugar and salt to prepare a mixture. Now boiling point and melting point are constant for a particular compound. This means what? This means the melting and boiling points of a compound are usually sharp and fixed. But melting and boiling points of a mixture are usually not sharp and fixed. Then energy is given out or in to prepare compounds through chemical bonding. Like compound formation is accompanied with absorption or evolution of light, heat or electrical energy. Here there is no or little energy transfer. Means heat, light or electrical energy may not be evolved or absorbed during the formation of a mixture. Now one more difference is it is compounds are always homogeneous in nature. Mixtures are usually heterogeneous except in solutions. This is all about the difference between compounds and mixture. One more figure I want to show you about the difference between compounds and mixtures. You can see in the figure and you can correlate that the compounds have a definite composition. As you can see here, the composition, the arrangement of particles is same. It has a definite composition, whereas mixtures have a variable composition on the other hand. So this is all about for today's class. Revise the chapter. Thank you.